for Year 10 Methods Pathways, we're going to look at question 10 from exercise 6.2. So which of the following statements is incorrect? Now we've got a right angle triangle here, so let's take that into mind when we're looking at option A. The length of the sides labelled x can be calculated using Pythagoras' theorem. We can, because we have A and B, and we're trying to work out C. So using Pythagoras for a right angle triangle, we can do that. So A is not correct. Sine of 48 equals 6 over x. So let's label the triangle. We know that that's the opposite side, that's a hypotenuse side, and that's the adjacent side. So sine of 48 is sine soc katoa. Soc is opposite over hypotenuse, so opposite is 6, hypotenuse is x, so sine of 48 equals 6 on x, correct? So that's not what we want. The unmarked angle in this triangle is 42 degrees, so we know that the triangle adds up to 180, so the unknown angle must be 180 minus 48 minus 90. So minus 48 minus 90 is minus 138, so to get from 138 to 180, you need 42 degrees. So that is correct. So that's not what we want. Cosine of 48 is 8 on x. So ka is adjacent over hypotenuse. Adjacent is 8 divided by hypotenuse was x. That's correct. Because cos of 48 equals 8 on x. Tan of 48 equals x on 8. Toa is opposite over adjacent. So opposite is 6, adjacent is 8. Now, as you can see, we've got x over 8 here. That's not correct. So our option E is what we want as the answer. Okay, so we'll go to question 13. A right-angled triangle has an angle of 54 degrees as one of its acute angles. Using 3 different pronumerals to represent side length, draw a triangle. So we'll draw a diagram of a triangle using the measurements, including the measurement of the other angle. So I'm going to draw a right angle triangle. I know that one of the sides is 54 degrees. So it's right angle, so one of the sides is 90. And we need to find the value of the other side. So 180 minus 54 minus 90, so that's minus 144. You need 36 degrees. Oops, you need 36 degrees to make that equal to 180. So that's 36 degrees. I'm going to label this A, B, C. That's arbitrary. Okay. So it says write down the value of sine 54 and cos 54 using the pronumerals. So we're not using a calculator. We're using the pronumerals. So again, SOHCAHTOA, sine of 54 degrees is given by opposite over hypotenuse. The opposite side of 54 is B, and the hypotenuse side is C, so it's B over C. Cosine of 54 degrees, we know it's ka, so cosine is given by adjacent over hypotenuse. So the adjacent side to 54 degrees is A, the hypotenuse side to 54 degrees is C. Okay, so that's all it's asking you to do. Then part C, find the value of sine 54 and cosine 54 using a calculator, round to 4 decimal places. Okay, so we have to use a calculator, so let's go. I'm on my main menu, I click keyboard, I click trig, I go sine of 54, enter, cosine of 54, enter. Okay, so sine of 54 is 0.8090. Cosine of 54, if we go back to the screen, is 0.5878. Round to 4 decimal places, 0.5878. Okay, so we've done that part. Now, we want to use the answer in C, so answer here, to show that the value of sine 54 squared plus cos 54 squared equals to 1. So we want to prove that 0.8090 squared plus 0.5878 squared, because that's a numerical value of both of those ratios. Want to prove that equals 1. So I'm going to go 0.8090 squared plus 0.5877 squared. Okay, we got 0.9998. If we round it to 4 decimal places, that actually comes 1. So yes, that's true. Okay. Use your answer in B to show that sine 54 squared plus cos 54 squared equals 1. So we're doing the same thing, except we're using what we have in B. So sine 54 squared is B over C all squared. Cosine 54 squared in numerals is A on C all squared. Okay, we want to prove that equals 1. Okay, let's do this. We know B on C all squared using the index laws. We distribute the power evenly on the numerator and denominator, so that becomes B squared on C squared plus A squared on C squared equals 1. Now, since they're the same denominator, I can combine them. I can combine the numerators together on the same denominator. So that equals 1. Okay, we got B squared plus A squared. Now, I'm going to multiply both sides by C squared, so I get rid of this divide C squared here, but I introduce a C squared on the other side. Now, since the triangle is right angle, A squared plus B squared equals C squared. So therefore, when we rearranged it, we've actually proven that this is actually true. So by virtue of Pythagoras' theorem, these sine 54 squared plus cos 54 squared happens to equal 1. Therefore, sine 54 squared plus cosine 54 squared equals 1. Okay, so we've proven using just rearranging and Pythagoras that we've proven that A squared plus B squared equals C squared, and that's true. Okay, so we're just proving that this statement is actually true, which we did. Okay, question 14. The value of the tangent ratio for each of the two base angles of a right angle is isosceles. So we're talking about isosceles triangle here, and we're talking about the two angles here. So it says the two base angles in a right angle isosceles triangle, so this is a right angle isosceles triangle, is 1. The value of the tangent ratio. Okay, let's call this side A, okay, and if I divide, I'll call this side C. Okay, so if I divide this triangle in, well, I don't need to divide in half. I know, I'll call this side C. I know that I'll call this angle B. I'll call this angle theta and call this angle B. Okay, so we know that the tan of theta, so I'm just referring to this angle here, we know that tan of theta, the opposite side is A, is opposite over adjacent. The opposite to the angle's A, and the adjacent side is also A, because it's a isosceles triangle. Okay, so that equals 1. So if I do the same thing for beta, if I go tan of beta, I can see the opposite side is A, at the adjacent side is also A, so I get a ratio of 1. So we can see that tan of theta equals tan of beta, which equals 1. And the reason why is because this triangle is actually symmetrical, so which is why we're going to get the ratio being the same. they're like mirror images of each other. So whatever we get in one, we also get in the other. So hopefully that sort of explains how this all works.